Okay, 6.3 and 6.4 are really closely related. 6.3 is an intro to factoring, mostly with GCFs, and 6.4 is factoring trinomials in a simple case. So I'm just going to start by talking about what a factor is. We've heard this term, what is factoring, but maybe you haven't heard, or maybe you don't remember how factoring is related to polynomials. So you've probably heard of factor in the sense that factors of 18 would be 1 and 18, 2 and 9 and 3 and 6. They're numbers that when you multiply together you get 18. You could break 18 down into a factor tree and end up with the prime factorization. So 3 times 3 times 2 is equal to 18. It's something that's unique to 18. So what is a GCF? Maybe you've heard this term before, maybe not. Hopefully you've used it with integers. It's a greatest common factor. So basically you look at the factorizations of the two integers you were looking at, and you would take out whatever they had in common. So if you had 12 and 18, 12 breaks into 6 and 2, 18 breaks into 6 and 3. The GCF here, the greatest common factor, would be 6. So how do we factor using GCFs? Here's what we're going to do. We're going to break down the terms into the smallest possible pieces and then take out anything they have in common. So if I have 2x squared y to the 6th plus 6x y to the, we'll say 4th, I'm going to factor everything down and then take out what they have in common. I do this with addition or subtraction. I don't do this with multiplication or division because remember, I could simplify that if it was multiplication in here. I would multiply the coefficients, I would add those variables if it was multiplication. However, since it's addition, I can't combine that at all, so I'm going to factor. I'm going to take out the GCF. So this 6 is really a 2 times a 3, so I can take out a 2. They both have a 2 in common. Here I have, this is really 2 x's. So I can take out an x, and this will still have 1 x to spare. If I move this 1 x out here with that one, I still have 1 left over. Over here, this x is going out here, and there isn't going to be another x. So plus, let me take what's left of these pieces. You put whatever isn't factored out back in the spot of it. So that x left, and then I can take out, this is really 4 y's, y. This is really 6 y's, 1, 2, 3, 4, 5, 6. So I can take out 4 y's. So I'm left with 2 y's here, and that's it. I don't have any x's or y's on the 3. So that would be the factored version of 2x squared y to the 6th plus 6x y to the 4th. Essentially, you're undoing the multiplication that you would have done. If you want to check your answer, you just use the distributive property. I would take this whole thing, multiply it by this whole thing, multiply it by this, and make sure that what I ended with is what I started with. So why do we need to factor period? Well, we need to factor because this is going to get into basically all of the rest of our algebra and then into calculus and all the different levels of calculus. You need to factor because it's going to help you find zeros of polynomials. It's going to help you simplify rational functions. This is really a key concept in algebra, and it's really, really essential that you learn how to factor and practice factoring because it's not something that goes away. So 6.4 is factoring trinomials. If you remember, a trinomial is something that has 3 terms. We're going to fill out this little chart about how to factor specifically quadratic trinomials. So when factoring polynomials, we're going to ask ourselves a series of questions that will lead us through the process. I'm not sure if you guys have ever seen a chart like this before, but we're going to get into ask one question, and then based on the answer, we follow that path, ask the next question, based on that answer, you follow the other path. You might have seen one that's like, should I get out of bed today, or should I go to school? And then it's like, well, do you have an important test or quiz? No, stay home. Yes, maybe you should go. And then you like ask yourself more questions. It's just like this. Okay. So I'm going to start with my first question is it a quadratic trinomial? If you remember, that means that it's something like this. Ax squared plus bx plus c. Quadratic, meaning degree 2, trinomial, meaning 3 terms. If the answer is yes, I would go that way. If the answer is no, then it's going to be a special case. We're going to deal with special cases later. Right now, we're just going to focus on the simplest version, which is quadratic trinomials. So otherwise, it would be a special case, and we're going to see other notes eventually. Right now, we don't have other notes for that, so don't go looking back in your notes. This is it for now. So our next question is the leading coefficient a 1? So is the leading coefficient a 1? And we're going to talk about what that means. So when I have ax squared plus bx plus c, oh, no question mark there. The coefficient attached to my highest exponent is my leading coefficient. So I want this number to be a 1. If it's not, it's going to be another special case. So I'm looking for that. So if our answer is no, I say, is there a GCF? If there is, yes, no, those are my options. If there's not, it's a special case. We're going to deal with that later. If there is, I'm going to factor out the GCF, so A is equal to 1. That's going to lead me, notice I don't have any other options in this box, that's going to lead me back into this box where I would have gone had the original answer been yes. So now here I am at yes. Is the leading coefficient a 1? So here's my next question. What is the second sign in the trinomial? So here's what I'm looking for. In my trinomial ax squared plus bx plus c, I'm looking at this right here. Is it positive or is it negative? It could be either, and I just want to know which one it is. So just because I write it as ax squared plus bx plus c, remember it could really be plus a negative c, so it really could just be a minus there. So I'm going to put a plus here and a minus here, and that's going to guide my next question. So now, if it's a plus, I'm going to look for factors of c, meaning the constant on the end, that add to give me b. So in ax squared plus bx plus c, I'd be looking for factors of c that would add to give me the number b. Remember, a, b, and c are numbers here. They'd be constants. If it's a negative, I would look for factors of b that subtract, factors of c that subtract to b. So I'd be looking for ax squared plus bx. It would say minus c, and I'd be looking for factors of c that subtract to give me whatever number b is. It might be a little confusing right now, just bear with me till we start to do some examples. So again, I have no choice but to continue on in this path. So the question is the same for both of them. So I'm going to write it in one and put it in both. What is the first line? So in my ax squared plus bx plus c, this right here is my first sign. So again, this is going to be the same question, so I'm just going to copy and paste it into that one. We'll deal with that in a second. But if this is the case, if the first sign is positive, both signs are positive. If it's negative, both signs are negative. All right, if I had gone down this original path of a negative, and then what is the first sign? This is where I'm going now. So I'm going to say if the first sign was positive, larger number is going to be positive, smaller number, negative. If my first sign was negative, my larger number will be negative, and my smaller number will be positive. This might seem a little confusing right now, so let me really explain and then do an example. When I have a quadratic trinomial, if I'm going to break that down, if I want an x squared, that means I multiplied an x times an x. X times x would give me x squared. So essentially, I multiplied two linear binomials to get me a quadratic trinomial. So in the end, whatever my quadratic trinomial started out as, let's say, we'll see an example, but I'm going to break it into two linear binomials that are being multiplied together. So let me recap. I'm going to ask myself the first question, quadratic trinomial. If it's not, we're not going to factor it this way, so we're going to go to a special case. If it is, and my leading coefficient is a 1, I'm good to go. I follow my path. If it's not, I check for a GCF. If there's no GCF, it's a special case. If there is a GCF, I factor it out so a is equal to 1, and I follow my path. I look for the second sign. The second sign tells me what I'm going to do. The second sign is positive. I'm looking for factors of c that add to b. If it's negative, I'm looking for factors of c that subtract to b. If I was adding, so here I'm down this path right here, both of my signs are going to be the same. So either they're both positive or they're both negative, and that the first sign tells me that. If I go down the other path, so I'm looking for factors of c that subtract to give me b, the signs are going to be different. And the first sign tells me what the larger number is. So if the first sign is positive, my bigger number is positive. The first sign is negative, my bigger number is negative. So let's do a quick example. Don't worry if you're a little confused on these. We're going to do tons of practice in class. I just wanted you guys to get the notes down and hear a little explanation. So let me do this. Okay, as I said, if you're a little confused, don't worry about the examples and understanding how to do it and all that. We're going to do tons of practice in the coming days. I really just want to make sure you have the notes down and you at least hear it and the idea is introduced. Look at this first example. I pulled up the chart here so we can follow along as we go. It says, is the example a quadratic trinomial? So I look at this example right here and I ask myself, is it a quadratic? It's a degree 2 and has 3 terms, so it is in fact a quadratic trinomial. That tells me in the end I want to have something like this. I'm going to have two linear binomials being multiplied together. So I ask myself, is the leading coefficient a 1? Is the number in front of this a 1? Sure is, so I'm good to go. I hop right into this path right over here. The answer was yes. So what is the second sign? This is the step I'm on. The second sign is this right here. In this case, it's a plus, so I follow the plus. Okay, I'm looking for factors of c that add to give me b. So factors of c in this case is 7. So factors of 7 that are going to add, factors of 7 that add to give me 8. Well, 7 and 1. There we are. So I'm going to put a 7 in here and a 1 in here. It doesn't matter. I could have done this as well. Order doesn't matter. Multiplication, commutative property tells me that. So now I go to my next part, looking for factors to see that add to b. What is the first sign? So the first sign in this case is a plus. That tells me both of my signs are going to be positive. I put a plus here and a plus here, and this is my final factored answer. If I had multiplied those two back together, I would end up with b squared plus 8b plus 7. Again, please don't worry if you're like, this idea is so foreign to me. It is a tricky idea. Just worry about getting the notes down, read through your notes, and maybe try the next example, but we'll do plenty of practice in class.